Hey everyone, welcome to this session on mastering mean squared error, or we simply call MSE. So, whether you are new to machine learning or already building models, you've definitely heard the term. But what does it really mean and why it is so important? So, today we'll break it down step by step and what it is, why it matters, and how it works mathematically and where it shows up in real world scenarios. So let's start by understanding what this mysterious term mean squared error really means. So in today's video, we'll be covering the introduction to the mean square error and the importance and those applications and the formula impact and the practical examples and why squaring those errors and advantages of MSE. Yeah. Think of MSE like playing that game. Here you can see, right? The bullseye is the actual value where we have to hit, right? So your darts are the model's predictions. So the closer you are to the bullseye, the better is your hit. So but here's the catch, like if you miss by a lot, you get punished much more heavily because we square the errors. So MSE is simply the average squared difference between what your model predicts and what's actually true. Okay, so a lower MSE means your predictions are closer to reality, while a higher MSE means your model is way off. Okay, so now we know what MSE is, but you might be wondering why does it means matter so much in machine learning. So let's explore that. So MSE is just isn't just some random formula. It's a key metric for evaluating models. So, for example, when comparing models like we say linear regression versus random forest, whichever has the lower MSE usually performs better. So during training, most algorithms are designed to minimize MSE, so it acts like guiding compass. And in real world use cases, MSE ensures safety and reliability. Imagine predicting patient recovery times. A smaller error might be okay, but a big error could be dangerous. So MSE penalizes those big mistakes much more and making the model safer to use. So yeah, uh, we see the MSE is useful across multiple domains, but to really trust it, we need for understand the math behind it. So let's break down the formula step by step. Yeah, the formula might look a little intimidating at first, but it's actually simple. So for each data point, take the actual value minus the predicted value. So that's your error. The square it and so the negative don't cancel positives and bigger mistakes get punished more. So finally, the average of all squared errors. That's your MSE. So this makes it independent of dataset size, so you can compare models fairly. And formulas are nice, but nothing makes sense until we try on an example. So let's actually calculate MSE on a small dataset to see how it actually works. So yeah. Uh, Here we have a simple data set. Suppose the actual values are 3 comma 5 comma 2 and the model predicted values were 2 comma 5 comma 4. So first we'll calculate errors. Here you can see calculate individual errors, which is yi minus wi. So the data point 1 will take a 3 minus 2, 5 minus 5 and then 2 minus 4, which is 1, 0 and minus 2. So these are the raw differences between the actual and predicted values. Now we'll square each error. So we got 1, 0, minus 2, right? So we'll square all these values. So for 1 square is 1 and 0 square is 0 and minus 2 square is 4. So now how squaring these values positive and amplifies the larger error. Now we'll calculate the mean squared error. So sum of the squared errors and we'll divide it by n, which is number of data points. So here we got 1, 0, 4. So 1 plus 0 plus 4 by 3, which comes to the total of 1.67. So this is how it actually works. So this is how the mean squared error works. So now we'll see why we square errors in a deeper look. So for the first reason is eliminating negative values. Squaring errors eliminates negative values. So when we sum raw errors, positive and negative errors cancel each other out. So by squaring errors, all errors contribute positively to the total error sum. So the reason two is penalizing larger errors. So squaring gives greater weight to larger errors. An error of 1 results in a squared error of 1. While an error of 10 results in squared error of 100. So this characteristic is vital in applications where large errors are more detrimental. So squaring errors serves crucial purposes. It eliminates negative values and penalizes larger error disproportionately. So providing a comprehensive measure of a model's accuracy. So few advantages of mean squared error are easy to compute and understand, and it is widely used and standardized, and it is sensitive to larger errors and differentiability. So that's it. Uh, Thank you for watching. Hope you guys understood.